which says that I'm supposed to express this one, sine of 90 degrees minus x plus sine of 90 degrees plus x equals. So for these ones I'm going to use two sum and difference formulas. One of them is that sine 90 degrees minus x is the same as sine 90 degrees times cosine x minus cosine 90 degrees sine x, and the other one is plus sine 90 degrees cosine x plus sine cosine 90 degrees sine x. And that, therefore, of course, this is a 1 here, so that's a cosine x. This one here is a 0, and this one here is a 1, so it's plus cosine x. And this one again is a 0, so I'm going to come up with 2 cosine x. And when I look at the right answers, it's this one here. Is that what I did? Yep, 2 cosine x. Okay, so Prom 11 says, from the list below, find the expression equivalent to sine 60 degrees, and then it gives a few choices here. And then, of course, there's the double angle identities in here for this particular problem, so that must have to do with it. And the only thing that, when you look through this one here, the only thing that would be applicable to the sine 60 degrees is sine 2a, which would make the a 30 degrees. So sine 2 times 30 degrees, and then that would turn into 2 times sine 30 degrees cosine 30 degrees, and there is the correct answer. And the next problem, if tangent A equals negative square root of 5, find tangent 2A. Of course, that would mean that I need a double angle formula for the tangent, and it's in the previous problem, so tangent 2A is going to be either this or this. The two are, of course, totally equivalent. I'm going to take the first one here. It's quicker to substitute in that negative square root of 5, so I'm going to do that. And I need to look at it too, and then it's going to say for, let's see, question 12, that tangent A equals the square root of negative 5, and then find tangent 2A, and then I'm going to look at that formula that is given on the test and the exam, and of course it's in the book too. Again, I need that fraction bar, and maybe I should make this a thinner line. There we go. Yeah. Alright, and then it says 2 tangent A and 1 minus tangent A squared. And then I plug in the numbers. So 2 times negative square root of 5, 1 minus negative square root of 5 squared, so equals, let's see, negative 2 square root of 5, need the fraction bar, and square root of 5 squared is 5. It's not 25, it's 5, because the square gets rid of the square root. The negative squared is a positive, so I'm going to have 1 minus positive 5, which is going to be a negative 4. The negatives, of course, divide out, and it's 2 over 4, which is 1/2. Square root of 5, and I'm going to look at the possible answers, and that would be this one here, square root of 5 over 2. Okay, and the next problem, question 13, simplify the expression. I have done this several times in eLive, and I would just do the following. I would do cosine pi over 6 is the same as cosine of 30 degrees, which is the square root of 3 over 2, and sine pi over 6 is the same as sine 30 degrees, which is the same as 1/2, and then plug in those numbers and I come up with the right answer. And previously I was thinking, gosh, why is that problem in there? What does it really have to do with any of these identities? Well, it turns out it does. Notice that it says cosine squared minus sine squared, and I go back a couple of problems, and here it says cosine squared minus sine squared, which means this one is cosine 2a. Let me double check that. Yep, that's what I have to do. So I'm going to use this identity right here, which means it's going to turn into cosine 2a. So I'm going to do that. So this is problem 13, and it says I'm supposed to simplify this expression, cosine squared pi over 6 minus sine squared pi over 6. And again, I'm going to look at this one here. So this one right here will therefore be cosine 2a, so cosine 2 pi over 6, cosine 2 pi over 6, which is cosine pi over 3. And now I do need to have memorized my basic numbers. This one is the same as cosine 60 degrees, and I do need to know that this is 1/2, which is one of the possible answers. So when I go down here, there it is. There's the correct answer. Even if I don't have this one here memorized as being 1/2, well, I can legally cheat, so to say, taking the graphing calculator, making sure that I'm in radians. I am, and then just type in cosine pi over 3, and there's the 1/2. Okay, the next problem. Okay, so question 14. If sine A equals 4 over 5 with the angle A in quadrant 2, find cosine A over 2, and apparently this has to do with half angle formulas, so I have to do something with this one here and substituting that one in. Okay, I'm going to push this to the side so I can